Hello class, this is Marcella, and today for this lecture we're going to be talking about tree measurements and calculations. So the objectives for this lecture are to review how to measure tree diameter and height, and also to be able to calculate basal area per tree, trees per acre, and basal area per acre for fixed and variable radius plots. So the importance of understanding this is throughout the semester in silviculture, we're going to be reading peer-reviewed papers and also talking about how we manage stands. And these numbers of trees per acre, basal area per acre, diameter and height are really going to factor into how we talk about that manage and putting some numbers to quantifying silviculture and objectives. So before listening to this lecture, you should have listened to two of those YouTube videos that were posted on Moodle that go into detail on how to measure diameter with a logger's tape and how to measure height with a clinometer. So this should be a review on this. So DBH, or diameter at breast height, is measured at 4.5 feet above the ground on the uphill side. So with the use of the measurement of calculating diameter, we can calculate a lot of other things. Using this one measurement, we can calculate volume, density, composition, and structure. So this is a really easy, useful measurement. And when you think about it, you're really hugging a tree when you take DBH. It's basically you're becoming a tree hugger and getting a measurement for a tree. So when you take a DBH, you can think of yourself as a tree hugger. So there's all kinds of rules when we think about how we measure diameter. So in a very perfectly level situation, 1.3 meters or 4.5 feet, we measure, it doesn't matter where you stand because it's going to be the same here as here as here. So it's 1.3 feet. However, when we talk about a slope, again, remember we want to stand on the uphill side. And that uphill side, if there's leaf litter or something else, you want to brush it away and get at the base of the tree. And these other examples just kind of go through how to measure DBH given some example examples. So if you're down in cypress swamps and you have these very large root systems, how do you measure it? What happens if you have a forked tree? What happens if you have two trees? So this goes through all those different scenarios. But for this class, we're going to be just talking about, we're just going to be kind of assuming this or this situation where we're measuring trees on the uphill side, 4.5 feet above from the ground at breast height. So measuring height, that's another important tool, another important measurement we get when we go out in the field. So diameter, DBH, and height. So clinometer is a common tool, and this in the example that you saw, he used a centro clinometer. Another way is a laser hypsometer, but with that clinometer, generally, depending on the device, but in our case, we go 66 feet or a chain, and we measure the top and we measure the bottom. And this gives us an idea of productivity, site occupancy, and just general forest health, and competition. So height and diameter, with those two measurements, we can tell a lot about our forest. So we can measure, so this is just talking about individual trees, individual tree measurements. But we also want to do more than just individual trees. We want to look at measuring multiple trees in a plot. And we can use this in a fixed area plot or a variable radius plot. So these are two different kinds of plot measurements, two different kinds of plots that we can use. So a fixed area plot, exactly what it sounds. It's a fixed area. You measure everything within a certain area. This could be in a circular plot. This could be in a square plot. This can be in a transect. But the main thing is it's a fixed area. And so here are some of those common values or radiuses for fixed circular area plots. We use a lot of circular area plots in forestry. And you can see, again, this is plot size in acres from everything from a 1/5 acre plot to 1/50th acre plot. So again, a fixed area plot, measure everything within a certain area. A variable radius plot is a little different. It's a method of sampling based on tree size rather than its frequency of occurrence. So what does this exactly mean? So we'll do this out in the field, but you find your plot location, and then you swing a prism or another tool to determine which trees are in. And which trees are in are based on its diameter, and it's based on that tree size. So we can see a small tree gives out a really relatively small size, whereas a bigger diameter tree gives off this bigger size. And you're sitting at center and you're using this tool, a prism, and you're going around and looking at each individual tree. So what does that look like? So you have this prism and it distorts the light and it looks at the proportion. So it gives you a basal area. It gives you an idea of the amount of basal area. So prisms, you look through and it distorts the light, and based on how the basal area factor, so your basal area factor can be 10, so corresponding to 10 square feet of basal area per acre, 25, whatever. So this prism, you swing it around and you look at trees. And you can say, so for example, this bigger tree, this could be this one. So you're sitting here, you're looking through your prism, and this distorts it. And where it overlaps, you see this is a hit, or a tree is in. Whereas the smaller diameter tree, this could be this one. And you see there's no overlap. So this tree doesn't fit, so it's out. And if we drew these radiuses, we would something like this. So we would count 1, 2, 3, 4. So it's a really easy way to estimate basal area per acre. So when we're using a prism, we can estimate and know if we were on this plot center, there's 40 square feet of basal area on this plot, basal area per acre on this plot. So I gave you one example of how we calculate basal area per acre using prism plots or variable radius plots. We're going to go through this example, and we're going to also do this outside on class, talking about tree calculation. So how do you calculate basal area per tree, basal area per acre, trees per acre? So I'm going to go through some of these calculations, and a good thing is if you don't have a piece of paper and your calculator and a pen and paper, press pause and get one, because it's just better to kind of work through this with me. So press pause, get that stuff, and we'll work through these tree calculations. So basal area per tree. So hopefully this number has been kind of ingrained in you from other classes, that 0.05454. So this is how you calculate basal area per tree. 0.05454 times your dBH squared. So if you measure your dBH in the field, square it, and multiply it by this number, you get your basal area per tree. And your unit of measurement is square feet. You can also do this if you have a metric. So again, 0.007854 times dBH squared. This again gets your basal area per tree in square meters. So now let's move into some of the bigger calculations. So this kind of serves as our base. We'll use this basal area per tree in calculating other measurements. So our fixed area plots. Again, a fixed area plot is just a fixed area. So maybe it's a 5th acre circular plot. Maybe that's a 1/100th square plot, but it's a fixed acre. And so this makes calculating trees per acre really easy. So number of trees times the inverse of the plot size. So on a 10th acre plot, each tree represents 10 trees per acre. So trees per acre, again, number of trees, so 10th acre plot, each tree represents 10 trees. So example, we had 2 trees on a 1/10th acre plot. 2 times 10 equals 20 trees per acre. Basal area per acre. It's a little bit different, but still not too complicated. So we take the basal area per tree times the inverse of the fixed area plot, and we sum all those calculations to get our basal area per acre. So for example, we have 2 trees with 5-inch diameter in a 1/10 acre plot. So again, we got to calculate our basal area per tree, 0.05454, times our DBH, 5 squared. This equals 0.136 square feet. This is just based on one of those trees. So let's calculate the basal area per acre that one tree represents. We multiply this by 10. So multiply our basal area per tree times our inverse of our plot area. And since we have 2 of those, we're going to multiply it by 2. So we have 2 5-inch trees. This gives our total basal area per acre from that plot as 2.73 square feet per acre total basal area for the plot. So this is a pretty low density plot. Variable radius plots, again, there's trade-offs, and one measurement is usually simpler than the other. So for basal area, the basal area per acre is really super easy to estimate, and it's one reason why foresters use this, because you can calculate your basal area per acre right when you're in the field. So it uses your basal area factor, so again, the type of prism you're using, so maybe it's a basal area factor of 10, maybe it's 20, maybe it's 5. But each tree represents whatever that basal area factor is. So our basal area factor of 10, each tree represents 10 square feet of basal area per acre. So you take your number of trees times your basal area factor. So again, we have these 2 trees in our plots using a 10 basal area factor prism. Our basal area per acre is 20 square feet per acre. The trees per acre in the variable radius plot involves a little more calculation. So we have our basal area factor, and we divide it by our tree basal area. So this is the basal area of that individual tree, not the basal area of trees per acre. So we have 10. We have our 1 8-inch tree. So we calculate tree basal area equals 0.35 square feet. And then we go 10 divided by 0.35. So that 8-inch tree represents 29 trees per acre. What can these numbers tell me? So what if I said there was 50 trees per acre? Take a second, pause. What does that look like to you? So what does 50 trees per acre look like? Well, it really depends. It could be 50 really big trees, maybe greater than 15 inches in diameter, or it can be really small trees, such as 2 inches in diameter. That's going to be a really different type of forest. Again, so we think about this. What does 45 square feet of basal area per acre? Sorry, this should be per acre. Again, alone this number means nothing. Together we can get a picture of the stand. So this is just the example, and these are numbers that are not taken from these actual stands. So let's say we have an average DBH of 12 inches, our trees per acre is 150, and our BA is 117 square feet per acre. Oh, something didn't come up. Okay, square feet per acre. So this looks different than, again, if we have an 8-inch tree, an average diameter of 8 inches, our trees per acre, again, is 150, so say these numbers stay the same. But our basal area is a bit different. So we can see that these numbers alone, trees per acre or basal area per acre, don't mean anything unless we have them together. So we need both of those numbers to really begin to kind of think about what we're seeing in the stand. And we'll discuss these kind of ideas of diameter distributions more throughout the semester, but just beginning to start thinking about them is how we can use diameter not only to calculate these values of basal area per acre or trees per acre, we can also use diameter to look at the stand. So we can use our DBH class. So this is, say, 2, 4, 6, 8, 10, etc. DBH class on the bottom, and a count or amount of basal area or the amount of trees per acre. But we can use some kind of count over here, and we can look at how either species composition, structure, we can look at how this is distributed, and we can see in even age stands, we can have this diameter in a single species, even age stand. This average diameter is going to be kind of unimodal, whereas in an uneven age stand with mixed species, we can see this kind of reverse J shape. So we're going to go into this in more detail, but these diameter distribution can give us a hint about stand history. We can also, again, this is another example of how spatial distribution, how these diameter distributions, they're exactly the same, but spatially we observe differences. So there's a lot of important, so these numbers alone don't tell you the whole story. It's piecing these different numbers together to start looking at the forest when you're out looking, bringing what you're seeing out in the field onto the page. So what about height? So we talked in a previous lecture, you heard about photosynthesis priority list. So how photosynthesis is allocated. So you have that basic maintenance, respiration, etc., etc. But we know that height comes before diameter. So height is a priority before diameter when we think about photosynthetic respiration allocation. So height can give us a good understanding about productivity and site relation, and we can use a tool called site index. So what is site index? Site index is the average height of the dominant and codominant trees on a site at a given age. This is your base age. So in the base age in the lake states is often 50 years. In the west it's 100 years, and in the south it's 25 years. So it will vary regionally, and it can vary based on the species you're using. So a site index of 60 means on average a tree will be 60 feet tall at age 50. So what does this mean? This can tell us a lot about the site. So we have our site index here, 40, 50, 60, 7. We have our total age here, 20, 30, 40, 50, 60, etc. We have our height. So this can give us information. So say a tree is 50 years old and it has a height of 50 feet. We say this has a site index of 50, and we can predict that the height will be just under 70 feet at age 80. If that same tree is 50 years old and only 40 feet tall, it has a site index of 40, and we see that at that same age of 80, did we say, it's only going to be 55 feet. So the site index of 40 is not as productive as the site index of 50. So we can kind of get an idea of relative productivity, richness, all this information based on age and the height. So there are some shortcomings, and we're going to talk about this more, but it works best in even age stands. There can be very little data supporting these curves, and the curves, we got out of here. The curves are not good with very young or very old trees. Also, we see these curves are very idealized, so they're very smooth. Trees don't. There can be different relationships happening in here. So again, there's some shortcomings, but this is a great tool if you have an even age stand and you wanting to compare productivity. We'll talk about this more, but this is just to give you that first glimpse into what we'll be doing. So in this lecture, we've reviewed measuring diameter and height, and we've also talked about calculating trees per acre, basal area per tree, and basal area per acre, and how those tools can be used. That is it for this lecture, and we'll see you in class.